exercise, it is this graph. So, and then the problem is asking us, please find the following: all the resources, all the process, to find the request edge, assignment edge, and then the second part is to draw the matrix. Okay. So let's start with this one: resources. So we have how many resources?
4.
1,
4.
2, 3, 4. Your resource will be always in the square in the rectangle. Okay. 1, 2, 3, 4. Okay. So this is the resource, and then from R1 we have only 1, right? And from R2 we have how many? 2, right? We have 2 R2. So you can write like this: R2 and 2 instance. Okay. It means we have 2. From the second resource we have 2. So R3 we have only 1. We have only 1. The next one is R4. How many? 3. We have R4 3 times.
3 times.
So we finished this one. Next is going to be the process. The process is always going to be square, okay? Circular.
3.
1,
Right.
2, 3. So we have P1, P2, P3. Right? So we found a set of resource, a set of process. Do you guys have any questions from here?
No.
No, right? So let's go to the next part. Find the request edge. So it is requesting. So request always, it is going to come from the process, it's going to go to the resource. So P1 it is requesting R1, right? So we have 1, we have 2, and we have 3. We have 3 request edge. So request edge is going to start from P1 to R1. So P1 goes to R1. So the next one is P2, R3. So P2, it goes to R3. And then the next one,
P4 to R2.
P3, it's going to the R2. So we have a P3 going to R2. That's it. So now we need to find assignment. So assignment, it means it is holding, okay? Assignment edge. So assignment, it will come from the resource. So this one. So resource number 2, we have 2. So one of them is assigned to the P1, and another of them is assigned to the P2. From the resource number 3, we have only 1, and it is assigned from P3. So in one word, we have how many assignment edges? Like 1, 2, 3, 4, right?
Yeah.
That's it. So let's write down assignment edge. So assignment edge is going to be from R2 to P1, R2 to P2, the next one R1 to P1, P2 to P2, the next one R3 to P3, 3 to P3. That's it. So basically solve the first part of the problem. Do you guys have any question from here? Yeah, okay. So now to draw the matrix. The matrix is super easy. So if you want, you can first find out the table, and then you can do the matrix, or if you want, you can immediately start the matrix. How? So we are going to write down P1, P2. How many? We only have 3, right? And then how many resources we have?
4.
1, 2, 3, 4. So R1, R2, R3, R4. And again, R1, R2, R3, R4. So this part, it is called allocation resource. It basically means hold. Okay? So P1, it's out of this one, which one is hold? And this one, it is called request resource. Basically means waiting. Waiting or request. Request. Alright? So P1, it is holding only one instance of the R2.
Yes.
So for R2, we are going to say 1. That's it, right?
Yes.
And it is requesting R1.
R1.
So that's it. All other is going to be 0. Okay?
And P2.
So P2,
It's holding
is
R2.
holding R1
R2.
and R2. So we have 2, right?
Yes.
So it is holding R1 and R2. So R1 is going to be 1, R2 is 1.
And 0.
So it is
Request to
requesting R3. 1. All other parts is 0.
Yes.
Okay. So now P3. So P3, it is only holding R3 and it is requesting
For R2.
R2. So it is holding R3, right? And then it is requesting R2. So all parts are 0. Okay? So this is the matrix. Yep. So if you want, you can do also table it. So what is going to be table? P1, P2, P3. And then for the table, you are going to write down, so this one is hold, and this one is wait. Okay.
No.
You can find out. So P1, it is holding only R2, right?
R2.
P1 is holding R2, waiting for
R1.
R1.
So P2, it is holding
R1 or
R1 and R2. It is waiting for
R3.
R3. P3, it is holding
R3.
R3. It is
R2.
waiting for R2. Okay? So, and then we have R4 is always available, right?
Yes.
Alright, so now we solve this one. Now we need to answer, is this a deadlock or not?
Not.
So we have 2 ways. You can go through 2 ways. The first way by looking at the graph. So if you look at the graph, basically P1 it is holding one part, it is going to the R1, and then the next is going to P2, P3. Okay. Does it look like the deadlock?
Yes.
Yeah. Okay, let's see. Let's see. So we have, so your P1, in order to get executed, it needs R1, and R1 it is held by P2, right? And then, so for this one, so basically your P1 is waiting for P2, right? And then we need R3 to get executed P2. R3 it's located on, so this one it is waiting for P3, right? So your P3 needs R2, and R2 we can find from P2 or P1. So basically it is gonna be like this, right? So it's basically stuck. It's basically stuck. So is this deadlock? The answer is yes. So that's it. Any questions, guys?
No.
Yeah? Shine?
Yes.
All right. So now take a piece of paper. Now we're going to have exercise. So